Hello children, we are in the third chapter, Atoms and Molecules. In the previous video, we learnt about ions. A positively charged or negatively charged atom or group of atoms are called ions. Positively charged ion, they are known as cations, and negatively charged ions, they are known as anions. Now today in this video we will learn how to write chemical formula. Now before starting with that, let us learn something about ionic compounds. So what are ionic compounds? The compounds which are made up of ions are known as ionic compound. Or I can say that the compound which contains equal number of positively charged ions, that is cation, and negatively charged ions, that is anion. Okay. Now in ionic compound we know it has cation and anion, both are opposite charges, so they will repel each other. So in an ionic compound both cation and anion, they are held together by electrostatic forces of attraction. Okay. And remember, in ionic compound it contains equal number of cations and anions. Ionic compound are composed of at least one metal and one non-metal. Example is sodium chloride. It's an ionic compound. NaCl. It is made up of equal number of sodium ions and chloride ions. Potassium chloride, KCl. It is made up of equal number of potassium ions and chloride ions. Ammonium chloride, NH4Cl. It is made up of equal number of ammonium ions and chloride ions. Okay. Now remember, sodium chloride, it contains one metal and one non-metal. Same with potassium chloride. It contains one metal and one non-metal. But over here we have an exception, ammonium chloride. It contains both non-metal. Okay. Now like we have learned about molecular mass, right? Molecular mass is the mass of molecule. So do we have mass of, can we find the mass of ionic compounds? Yes, we can find the mass of ionic compounds. But we cannot use the term molecular mass. Why? Because ionic compounds do not consist molecules. So for that reason we cannot use the term molecular mass. So we use the term formula unit mass. And this formula unit mass is calculated in the same way as we calculate molecular mass. That is by adding, taking the sum of atomic masses. Okay. So formula unit mass is the sum of the atomic masses of the atoms or ions represented by its formula. Now you can see over here, this is the framework or structure of sodium chloride. It is an ionic compound. You can see that the purple color ball indicates sodium ions and green color ball indicates chloride ion. Okay, so this structure contains equal number of sodium ions and chloride ion. Okay, now in an ionic compound, in this sodium chloride ionic compound, the ratio is 1:1. That is, for every one sodium ion, there is one chloride ion. That is why we have the formula NaCl. Because for every one sodium ion, there is one chloride ion. For that reason, and that is the reason, because of that it has a electrically neutral charge. The charge is 0. And for that reason we use formula unit. Okay. Let us find out, let us see an example of how to calculate the formula unit mass of sodium chloride. Now to find the formula unit mass, we should know the atomic mass of the atom and formula of the compound. For sodium chloride, the formula is NaCl. So formula mass of sodium chloride is equal to atomic mass. So what we will do, we will add the atomic mass of sodium and chlorine. Atomic mass of sodium is 23 and atomic mass of chlorine is 35.5. So when we add them, the answer will be 58.5 unit, okay, unified mass, and that is the formula mass of sodium chloride. Let us look at one more example. Calculate the formula unit mass of calcium chloride. Okay. The formula mass of calcium chloride is atomic mass of calcium plus 2 into atomic mass of chlorine. Why 2 into? Because you can see it is Cl2. Okay. So it is 2 atoms. So there are 2 atoms of chlorine. So 2 into atomic mass of chlorine. Now atomic mass of calcium is 40 and atomic mass of chlorine is 35.5. But we have 2. So 2 into 35.5. So when you multiply, you'll get 71. We'll add 71 to the mass of calcium. So the answer will be 111 units. That is unified mass. Okay. So this is how we find the formula unit mass. Okay. So remember, molecular mass is used for molecules and formula unit mass is used for the compounds which are made up of ions. Okay. So let us come to writing chemical formula. Okay. Now first of all, let us understand what is meant by chemical formula. What do we mean by chemical formula? Now chemical formula of a compound is a symbolic representation. Okay, it's a symbolic representation of its composition. Composition of what? Composition of molecules of the compound. Okay. Now to write chemical formula, we should know two things. One is symbols and combining capacity of the elements. We already know what are symbols. We have learned. Let us find out or let us learn how to find this combining capacity of elements. The combining capacity or power of an element is known as valency. Okay. Now this is a new term, valency. So the combining capacity or power of an element is known as valency. Now what is the meaning? What does this mean, combining capacity mean? So let us find out. Now when I say combining capacity, it means that whenever an atom wants to combine with another atom, so it has to either lose, gain or share electrons to achieve stability. Okay. So to become stable, or if an atom wants to combine with another atom, it has to either lose electrons, gain or share electrons. Then only it will become stable. The bracket you can say written octet state. I'll tell you the meaning of this. Now let us learn more about valency. Now this term valency is also there in your 4th chapter. So we'll study in detail about valency in the 4th chapter. Now valency. Let us find out how to, let us learn how to find the valency. Okay. Now in sodium, the electrons are arranged as 2, 8, 1. Okay. So this is the arrangement of electrons. You will learn more in detail in the 4th chapter how these electrons are arranged or what are the rules behind arrangement of electrons. Now this is an atom of sodium. You can see that the innermost shell, it contains 2 electrons. Then the next shell, it contains 8 electrons. And the last shell, it contains 1 electron. Just now I've told you, to achieve stability, an atom, it should have 8 electrons in the outermost shell. Then only it will follow the octet state. Now octet means what? Octet means 8. Okay, so if an atom has 8 electrons in the outermost shell, it will achieve the octet state or become stable. And in the case of sodium, it has only 1 electron. So to achieve stability, it should have 7 more electrons. So what it can do, it can accept 7 electrons, right? But we have already learned an atom, it can donate or it can accept only 3 electrons, not more than 3. So where sodium needs 7 electron, it is not possible. But sodium can do one thing, it can give, okay, it can lose that 1 electron. So if sodium loses that 1 electron, what will happen? Then the last shell, it will have 8 electrons, right? So it will have 2 in the inner shell and the last shell will have 8 electrons. So it has achieved the stability, or you can say it has achieved the octet state, right? So what is the valency? Valency of sodium is +1. Okay. So valency, or you can say that valency is the amount of electrons donated or accepted by the atom. That is the valency. So here sodium donated 1 electron and it got positive charge. So the valency of sodium is +1. Let us have a look at one more example. Aluminium. Now in aluminium the arrangement is 2, 8, 3. It means the inner shell contains 2 electron, the next shell contains 8 electron and the outermost shell, okay, or the last shell contains 3 electron. Okay, now it is 3 electron, correct? So for stability it should have 8 electrons. So what it will do? It will donate or it will lose that 3 electrons. So as aluminium loses that 3 electrons, you can see that now the last shell contains 8 electron. So it has achieved stability, or you can say it has achieved the octet state. So the valency of aluminium will be what? It has lost how many electrons? 3 electrons. The valency of aluminium will be +3. Okay. Let's take one more example. Example of chlorine. Okay. Now in chlorine, the electrons are arranged as 2, 8, 7. So you can see that the innermost electron, it contains, innermost shell contains 2 electrons. Then the next shell contains 8 electrons and the outermost shell contains 7 electrons. Okay. So if it gets one more electron, it will become octet. Okay. It will achieve the octet state. So chlorine, what it will do? It will accept. Okay. It will accept 1 electron. So as chlorine accepts 1 electron, you can see that the last shell has 8 electron and it has achieved the stability. Okay. So here, what will be the valency? So valency of chlorine will be -1 because it gained 1 electron. So and it has achieved negative charge. So the valency of chlorine is -1. Another example is of oxygen. You can see in oxygen the electrons arrangement is 2, 6. That is, the inner shell has 2 electrons and the outermost shell has 6 electrons, right? So for 8 electrons, so oxygen needs 2 more electrons. So what it will do? It will accept 2 electrons. So when oxygen accepts 2 electron, even the last shell, it is now complete. It has 8 electrons. So the charge on the oxygen is -2. So valency of oxygen will be -2. Okay. So this is how we this is how valency is found out. Now in the next video we will learn how to write chemical formula. Now we know what is symbol, we know what is valency, right? So with the help of both of these things we can write the chemical formula. I hope you have understood, children. Thank you.